It all depends on what software you use. OBS is different. This is better in my opinion, but I had to pay for the pro version. So anybody playing along with us at home, it is October 11th. It's Friday. It's a great day. It's also Flex Day. I hope you guys are excited about our stuff this afternoon. We're looking at this. We're talking about substituting in. When we substitute, a lot of times we substitute in for the X, but not always. So today we will start to see situations where we're substituting in for the Y. So if we go to do this, I always rewrite the original equation. Always. Right? I'm trying to train you guys with that as well. We always rewrite the original. Then to show that we substituted something, does anyone remember the suggestion I made for when we go to put that in, Mr. Dale?
Go 6 and then in parentheses you put whatever.
Yeah, we put it in parentheses because it helps us see there was an X there. Now it has turned into a 50. Now we could write 6.50 as multiplication, but also that dot can sometimes be confused with a decimal, which now we wouldn't do that, right? Because we know this is multiplication, right? We wouldn't do that. But some people might, and that's why the parentheses are safe and show us multiplication. Make this easy. What's 6 times 5? 30. Put the extra 0 on. Plus 3. So Y comes out to be a final answer of 303.
Should we write this 303 units squared?
So it's actually going to be 303 tiles is what we just solved for. So what the Y value was telling us was how many tiles are necessary to create the figure. Now, we can use like real world examples for things like this. I should go ahead and look at the next problem I put on your yellow sheet. I know it's not literally the next problem in the lesson. But go ahead and look at part A or B or any of those parts and try to start solving those. I want to pull up an example of a really cool real life example of where you would have to compute something like this. So one trend that has become popular is do-it-yourself projects that utilize like weird resources for a purpose, but then a lot of times you got to do the math yourself because like the hardware store can't tell you, I don't know, like how many pennies you would need to make a floor of it. So this would be a real life application of needing to set up a function to represent how much area does each penny take up compared to the area of the entire floor. And then we could solve the problem for how many pennies what we actually need. We can go to the bank, get that many pennies, and create some amazing designs. So these are all just pennies that you then dump epoxy over. Yeah, right? So then it's just 1 cent for each penny that's there, plus the other resources that you need. So there's probably some glue to stick them down potentially, and then the epoxy.
How much do you think?
So if we're going to bounce over here, look at A and B, and then we'll come back to do C and D. So I want to take random suggestions from random cards.
Really?
Yeah, really. That's why. We have 1/2 x minus 2 equals x minus 4. There are 4 correct options here. Just talk. Serena, give me one option, the option that you would take here. Do what? 2. With what? With 2? How do we do that? Do we subtract 2, add 2, multiply 2? Add 2, right? This minus 2, we can add 2. Now, I will say this is not the direct route that I would take, but it is a correct route. Serena turned down a road that I wouldn't, but it's okay.
It's not direct, but it's correct.
Yeah, she can still get there. So, Logan, because you don't have your yellow sheet, and like, we need to write down the original, right, and then write down the solution process, because you don't have it on the yellow sheet. Write the original, then write the solution. Guys, I tutored a high schooler last night that as I was checking through some of his work, he wasn't writing the in-between step. right? Like this, I found 2 mistakes. Just checking through his work for like, did you follow the processes? And I would ask him, what'd you do here? And he's like, I can't remember. And he'd have to look at it from it. Write the in-between. Please write the in-between. So now we get 1/2 x equals x minus 2. I need another option. Audrey, what would you do here? Audrey Gal, sorry. So, yeah, we have to subtract the x because we got to group our like terms together. So to get this x to group over there, we need to subtract an x. If I have half of an x and I take an x away, negative half x equals -2. Now, I'm actually glad that Serena took us this way because this gives me a nice opportunity to talk about a nice little strategy that we have. Yeah, sure. I think you probably do actually know what I'm about to say.
Since both of them are negative, you can just take the negative.
Since both of the sides, like both sides are negative, we can just poof, make it disappear. Now, why that works is what we're actually doing is multiplying by -1 on both sides. And remember, if I do it on one side, I got to do it on the other side. But I can do whatever I want. This is why algebra is so beautiful, right? There are very few rules. But one really important one is if you do it over here, you got to do it over there. So this now becomes half x equals 2. And if you took a different route, you may have gotten here without ever doing the negatives. What do I do with half an x, Charlie, to turn it into 1x?
Multiply it by 2.
We multiply it by 2. And x equals 4.
Wait, is for all the things is x equal 4 or are there multiple?
Oh, these are different problems. Yeah, I don't like that they use x for all of them. Sorry, I can't retype this because I cut it out of the thing I grabbed. The x's will have different values. So that x will be different than this x.
No, like I'm saying, is that equation like no matter what you do going to be x equals 4? Like, if you do it correctly?
So that is the only thing that it isolated to. So yes, that is the only one solution here. Now, if we ended up with a situation that was like half x is equal to half x, that's where we have more than one solution. Or if we have like something being squared, squares or cubes or, excuse me, things like that. Yeah, they make multiple situations. And we're actually going to look at why, right? I'm going to show you in the graphing utility why this happens. To make sure that we have time for that, let's bounce back to, I want to look at, this is in your book, right? So you don't have this on your yellow sheet, so graph paper, please. Graph paper, please.
Yeah. Okay, I see what I did.
Here, we're back. Now, if you have space on your yellow sheet, you might be able to squeeze this in. We're back at the big C problem. But when you told Lewis that he needed 303 tiles, he laughed at you. And he's like, yeah, that won't work because I only have 45 tiles. So Lewis wants to know, what figure would he be able to make if he only has 45 tiles? So now, how is this different than what we did before with the big C? How is this different there?
With the big C before, we had the input, but now we have the output, and we have to go backwards. So, but can I explain how?
Give me 2 seconds, okay? I'll come back to you. I promise I'll come back to you. What Bear said, so I got some people not listening. What Bear said was this is different because we've now been given the output, the result, right? They said you have 45 tiles. It's the result. But that's the why. We still have the same equation. So what Bear's about to talk through is how we find out what figure it is when we substituted this now. So please, on your paper, write out 45 equals our 6x plus 3, because that is still our rule.
Oh, should we put 45 in parentheses?
I like your thinking, but because it's alone, we don't really need to. You could, but I mainly do that when we're multiplying with it, just to clean things up. I like what you're saying. Yeah, I guess my rule isn't really a hard and fast anytime you substitute. It's more so when you substitute and there's stuff happening. So over here, there's a lot going on. That's why I like to put that in parentheses. It's never necessary. It's just a nice thing to do. You know what I mean? Like, I'm trying to teach you guys the best strategies. So now, back to bear, because I promised. I said back to bear. Oh, you can come up here. I don't care. You're writing in red right now, because I assume the next step is a red step. Okay, you jumped way too. Sit down. Bear's not wrong, but he's jumping steps, and that's my absolute no-no. My absolute no-no is skipping over steps when somebody else may not understand. So what Bear just wrote is right, and I know how he got there. So please do not think I'm saying Bear is incorrect, because he's good. We just got to write the process. So Bear, hear me when I say I would put a question mark next to that and say C. If what you wrote out was that work, because we want to write the work that gets us there, not just the final thing. So Avi, what do we do here?
What if I just subtract 3 on both sides?
Subtract 3 is a great way to start. This is how Bear got that 42 that he got. And then we divide by 6.
Why'd you write minus
Equals 7.
You're right, I don't know, because the pen was green. And now the pen is red.
Mr. Hudson?
Yeah.
We had our notes.
This is solving equations. Yeah, sorry, that was on the start screen, or like the beginning of the book screen thing.
Although, to be fair, I've written them
To
down
be
for
fair.
and quite a few homeworks. I've just kind of skipped a few steps, you know.
Any questions when we sub in the y?
No, but I like my equation.
Like I said, it wasn't wrong. I'm like here to teach, though. I gotta make sure people know how we got there. What about 84 tiles? This is your challenge. What figure would that be? You should know what to do to 84 because we're gonna do the same thing with it that we did to the 45. Right? We're gonna take away that constant that had been added and divide by that coefficient.
I have an answer.
This is 91.
Here.
90. That was 90. I know I jumped to 92 real quick for a minute, so that was just to kind of vamp for time away.
An odd X number.
An odd X number.
Okay, but so really, you'd only be able to. Never mind, I can't get out of it. Yeah, because these are algebra tiles. So you can't, like.
So, like my high schooler last night, this would be his next step, right? But he wasn't writing the this, and that's where I really have like a pet peeve.
Is that what?
Have to? No. Should you? Yes.
Were you getting very much mad at the high schooler?
Oh no, I love tutoring, man.
Who
Brennan-
is the high schooler?
I won't use first and last name because we're filming.
Okay.
But it was a student that came to Phoenix years ago. He's like a junior in high school now. So it's really fun to, like, when I walked in the library, I barely recognized him because I've seen him once in, like, the past year. But it's fun to hear, like, what life has going on. Like, he's about to get his license. Actually, he might only be a sophomore because he's about to get his license. Life's good, except he's struggling in math because he decided to take the honors class that we kind of talked about in here. But he was in regular math 2 last year. Now he decided to step up and challenge himself and take honors math 3 because honors classes look better on your transcript. He's struggling now because honors classes don't give you as much support. It's just like, okay, this is how it works. So this is it. Move on. Like, it's pretty intense. So that's why we're meeting now and helping him out. 60 would divide by 6, obviously, but that would leave me with 21 left over, right?
No.
Well, if I took 60 out of it,
Yeah.
but so what is this?
Okay,
Did anyone
fine.
do this division? What'd you get?
13.5.
Ooh, 13.5.
Really
So
chatting.
hold
No.
hands. Chill, man. Give me a hand of who can tell me what this actually means to us. Simon?
What were you mean by mean? But do you mean like 13.5? Are you saying that x is like a non-integer or?
What? So in this situation, x being not an integer, does that work?
Yeah.
Yeah. We
No.
Hey guys, notice that Simon's talking. You can't just talk over somebody. That's not how things work in society. You might see it on TV, but no.
X's can be not integers as long as when you plug it into the original equation, it still works.
I agree that this works in the sense of the equation, but if we think reasonably here, our x's are the figure numbers, right? So what we're hypothetically saying is we have a 13 and a half figure. There'd be something in between. We wouldn't. So what this actually tells us is there isn't a figure with 84 tiles. There's a figure with 87, though, because if I plugged in 87 and redid this math, it would work out. Because 87 minus 3 would be 84, and divide that by 6, that works. That'd be figure 14. So this is actually in between figure 13 and figure 14. Patrick?
So what if the answer be 13? You can't do 13.5.
So, if we had 84 tiles, we could only make figure 13. We can't make figure 14. Right? So if we're asking what are we able to make, Patrick's right on. We can make 13, we can't make 14. Thank you very much, sir.
Sad. You're only missing 3 tiles.
The only other thing that I'm really like critically focused on today is making sure that we're comfortable solving these multi-step equations. So take a moment, these are on your paper. Do B, C, and D. And then I want to just show you the answers, and if we have any issues, like if we got a wrong answer, let's talk about these. But if we don't need to, we'll just go ahead and use this time for practice work. So do B, C, and D, and this will take a few minutes. I'm going to turn the timer to 5, and I'm going to ask that we don't talk. Just solve it on your own. You can use a calculator if you need, but for a few minutes, just do this on your own. And the other parts of 92 that are on your yellow sheet. The packet from yesterday that I gave you, where it said this is classwork. Are you going to ruin it? Also, if you don't have your packet here, I'll scroll. I'll bring this back up or something. Remember, every equation that is set up like what we have has 4 correct steps that you could take. But before we get there, like in a situation like C, clean it up. Right? Clean it up. Put together like terms. We're all doing B, C, and D here. If you already did them, you can work on homework problems. They can jump down to 94. Right? Like you already solved all of 92. Yeah, nice. Use your time to do some homework. Okay, I hear some angry grumbles. Now the hard part about me going over the solution process, there are many solution processes that can get us to the same answers. That's why we're all doing this on our own first. What about C and D? Where are these? Yeah, but we need to solve C and D also. These ones. So that's what we're working on. Pencil in hand. Pencil in hand. If you've done B and C, show me, but like, I don't see it.
Did we just chill out?
Okay, I know the C got chopped out by the hole punch. So then part of D here. 2 more holes to solve. Where's your packet? Do you need another? You could be working on homework problems right now if you had it with you. Wasn't it somebody in here that I was talking about cars with? Right?
It's probably me, right?
My brother just texted me and he said, if you're free this weekend, I'm ready to drop the engine and the transmission in the Firebird. Which is always a fun text. Then you get to use an engine hoist and hoist it up and swing it in. Dude, putting in an engine with the transmission connected to it is like really particular because you have to work the angle and so you have to thread. If you take the front end of the car off, it's way easy. You just shove it in there. But without taking the front end, you have to get the engine to go in and the trans to not hit the floor or hit the car because it goes in at an angle. Take a car, take the hood off. Literally take the hood off. Don't just pop it. Take the engine out, take the transmission out. Put them together, and now put them in the car together. Because they were broken. They needed replaced. So, really, you don't do like, so in the factory, stuff wouldn't necessarily be all put together, fenders and all that sort of stuff. If you chop the front end off of a car, you've affected the frame. Like, a car has a rectangular frame that's all connected together. You can't just take it off. Like, so me saying that was like, oh yeah, if you just take the front of the car, you can't. There's no real way. You could take out the radiator, you could take off the front fenders, you could take off the front bumper. Well, yeah, you could, but then your car wouldn't drive right. You would have effectively broken your car. It's not the same. Welds are not as strong as, like, re-welding is not the same. Yeah.
My dad's 1966 Thunderbird.
I still want to see that, dude.
Yeah, he was working on it, and my dad went to a car show, and he was taking it out, and then he heard like a loud click and then a noise, and he just looked, and the wheels got all messed up, so he pulled it back in our garage, and
Yeah.
then the front wheel, when he turned to get it in, it like got launched back into the, like, and it's touching the fenders now.
Something has messed up real bad.
Yeah, he was just trying to replace the wheels, I think, and then it got messed up.
Something must have not gone back together correctly, or yeah, that's weird.
We just put a V8 engine in my friend's grandpa's car.
Avi?
When there's input solution, how do you write that blank?
We're about to talk about that. So we have 8 minus a quarter x equals half x plus 2. Multiple ways to start this, but the thing that sticks out to me is we only have one negative. Right? The 0.25 is negative. So if I add that, it gets rid of my negative situations. So I do that on both sides.
Why'd you do that?
I don't know. Okay? Don't ask questions about colors. They really just changed to a different color. I'm doing my best. Isn't that enough for you?
No.
Gosh, you guys are mean.
6 times 0.75.
There is no trying this.
Now, again, there are multiple ways to solve this. This is just the way I took. But at the end here, I have 6 is equal to 0.75x. We can do a division. You know, well, I won't choose orange. I'll do that in white. Ooh. Now, wait a minute.
That looks really cool.
Let's talk math theory for a moment. Let's talk math theory for a moment.
1x.
Dividing.
Whoa. That's
There, when you're done, I have something to say.
I didn't think
When dividing by a partial value, like a half, a third, a fourth, 3/4. Why?
Because it's like,
It's really tough to explain. Division by a partial. It's really tough to explain.
Well, I think of like 0.75 as 3/4,
Yeah,
and then you multiply it by, like, you multiply 6 by,
but why? You're about to tell me what to do, but why?
well, like, because,
You just want me to help you out. Let's say I'm buying pizzas for the class.
Oh,
Right? I'm not, but let's say I am.
I can explain it.
Okay, one more shot.
Okay, so when you divide by a partial amount, the reason it gets larger is because dividing by like 3/4, for instance, it's the same, like it ends up the same as multiplying by 4/3.
But why?
because keep change split.
That's not why. That's a rule.
That's exactly why it
So, guys, this is one thing about like a real like teacher that cares about you versus just somebody who wants you to score well. I don't care if you know the rule. I want you to understand the why. So hands out for just a second. Everything everyone is saying is rules. No one's telling you the why, Alex.
There are more partial integers in an integer.
You're explaining it very complicated. I'm trying to explain it with pizzas, but you guys won't let me. Hazel? I don't know. I can't even explain this example right now.
Basically, if you have 2 and you split it into halves, now you have 4 because now you have 4 pieces because you're splitting them in half.
If I have 2 pizzas and those will feed or divide to, right, divvy out to a fourth of the class, then how many pizzas do I need to feed the whole class? 8. So division by a fraction is bigger because what you're actually saying is this many accounts for that much of the situation. So what we're saying over here is 6 accounts for 3/4 of what we have, right? 6 is 3/4 of our quantity. So yes, like everybody said, keep, change, flip, or whatever else you want to call it. This turns into 8.
Yes, but I have another way of doing that.
Now that's a totally different 8 than this 8. Sorry, that example just ended up being the same.
Can I?
No, because I don't want to complicate people. Like, so I just don't want to confuse people. We're going to talk about one method.
Okay.
I know, but we also have limited time, and today's a Friday flex, and I'm trying to respect that. If we clean this up first, right, 0.5x plus 2, 2 plus 0.5, wait a minute.
It can be anything.
It's the same thing. So Avi brought up that great question. How do I actually write this?
X equals infinity symbol.
What is this?
A joint?
It's an arm, right?
Oh.
Close to an arm is an arn. This stands for, and I want you to write this out at least for the first time, all real numbers.
That means it's short for Arnold.
All your base.
It is not. It is an acronym.
Oh, I
It
have
is not an
neighbors.
abbreviation. It is an acronym.
I have neighbors in middle school.
And the symbol, notice how you're off topic, and I'm just going to continue teaching.
That is not an acronym.
The symbol is ARN. Okay, correct me, Logan. What did I say wrong?
An acronym is only when the thing actually spells out a real word.
You think ARN is not a real word?
What word is it?
I don't know, but earn is a word, right?
But that's not
Yeah.
art.
I mean,
Arnold.
Arnold. I might be a
Agree
word.
with Logan.
But
I don't disagree with him either. I just know math, and I say a lot of things wrong. And this is the first time dealing with people this smart. Now hold up! D, does that have one solution? Too many what? What's the solution to D?
It has one solution.
Hey, we're not packing up yet. Hold up. Who's got a solution to D? Oh, this is gamma. Oh, we are down. We're overtime. My bad. We gotta go. Okay, it's 11:08. I knew I was gonna lose track of time and lose time. What? This is gamma, right? It's 11:08. Yeah, I went over. Sorry, you're late. My bad.
No, actually, beta, gamma, delta.
Where are you going? Language arts? Dude, we're on a different schedule. I agree with you. That's why I messed up. I agree with you. Normally we have more time. Today we don't. So Simon, remember when we announced about Friday Flex and the gallery walk and everything else, and Mrs. Gordon in class probably talked about the different schedule today? We maybe showed you, like, we operate on different schedules a lot. So if you want to see it, here it is. Yeah, I promise you, I'm not lying to you. I went over time. Yes. When you eat food. It is at 11:52. It's after Delta. We eat. Yeah.